Hello, we're going to talk about section 2.3, linear functions and slope-intercept form. All right, so let's start with the basics. What is slope? Okay, so let's start with the blue line here. Okay, typically we write slope as the letter M. So here, our slope, we can count it, and we can count it, hopefully you remember this is rise over run. So I'm going to start at this point right here, and I'm going to go to the next point. Okay, and I'm going to label the rise over run. So rise. So I don't have to rise, I actually have to go down 3. So we do a down movement as negative. If it was up, it would be positive. And then we run. So run is left or right. So we have to run to the right. And with the number line, to the right is a positive direction. So positive 1. So the slope for the blue line is just negative 3. Okay. Ooh, didn't mean to do that. All right. So let's do the pink line. So the slope of the pink line, let's count it. It doesn't matter which point you pick. All right, we're just going to count it from one to the next. So I'm going to start here. All right, down here at the bottom. So rise. I'm going to rise 1, 2, 3, and I'm going to run 2. So I went up 3 and right 2. And that gets me 3/2. Ooh, sorry. All right. Again, we could have gone from this point here to this point, and we would have done the same thing, gotten the same number. So we would go down 3 and left 2, so that's negative 3 over negative 2, which is still positive 3/2. Okay, so we can also do it algebraically given the points. Let's see, so I'm going to change my color. All right, now we do rise over run. So rise was your up and down movement. Up and down is your y's. So rise is your y's. Oh, that I never caught how weird that sounds together. Okay, so it's your change in y. That triangle is delta, Greek for change, or at least in the math world it is. All right, over your run. Well, run is left and right, which is your x values. So your changes in y's over your change in x's. That's all you really need to know. So do the difference in y's, negative 5 minus 2, over the change in x's, 3 over 1, or I'm sorry, 3 minus 1. Now, I know I'm getting people out there who are probably like, oh, but Miss Cross, isn't the formula y2 minus y1 over x2 minus x1? Yeah, if you want to remember all that, go for it, okay? But I'm telling you, I get a lot of people that get confused with pointing that stuff in, all right? There's just too much stuff going on. So I just keep it simple. Subtract the y's, subtract the x's. Make sure you're going in the same direction, okay? If you want to do the formula way, fine, that's fine, but I'm not giving you that formula, okay? So we have negative 5 minus 2, which is negative 7, over 3 minus 1, which is 2. So the slope here is negative 7 over 2. Oh, I never circled that answer either. Okay. Now let's do number 2. Let's see, I'm running out of colors. How about purple? Okay, so the change in y's, so negative 1/2. All right, we went from there to 7, so minus 7, all over negative 1/2 minus 5/3. So for subtracting fractions, we need the same denominator, so I'm going to go ahead and change those. So I'm going to make this negative 1 over 2 minus 14 over 2. And the bottom, I'm going to make that negative 3 over 6 minus 10 over 6. So we subtract the top parts, we get negative 15 over 2 all over, okay, let's see, negative 13 over 6. So this is nice because we see that it's negative over negative, so we can cancel those and just make it positive. But if we don't, we can just keep going. Hopefully we know keep, change, flip. You keep the negative 15 over 2 the same. You change it from division to multiplication. And you flip the negative 13 over 6. Alright, so now we can simplify. Doesn't matter when you simplify, I like to do it first. Just makes things go faster for me. If you want to multiply and then simplify, go for it. Either way, you should end up with, what is that, 45 over 13. Okay, do not give me a decimal unless it's exact. So if the answer is 1/2, I'm fine with you writing it as 0.5. But if the answer is 1/3, you better not put 0.3. That is not the same thing. You could put 0.3 repeating, okay? But don't write weird decimals, okay? Leave it as your fraction, okay? All right, I'm gonna erase that so it's not on our copy. All right, so now let's talk about what slopes look like. All right, hopefully you noticed with the blue and the pink line that the blue went from the bottom left to the top right, so it went up. If we read it like a book, we're going up the mountain, okay? That would be a positive 3/2. The blue, we went down the mountain, so that's a negative, reading it like a book, okay? That was a negative, so we should know that you have a positive slope, looks like this, increasing. A negative slope looks like this, it's decreasing, you're going down the hill. And then you could also have, all right, two other weird ones, right? Your horizontal and vertical lines, okay? It's really important to know the difference here. A horizontal line and a vertical line. I get people who mix up the slopes all the time. So I like to picture, I'm going to do pink. All right, so I like to think of me running or hiking or really walking, let's be honest, okay, along this path. Yeah, I can walk up the hill. Okay, slowly, but I can do it. I can go down the hill. Yeah, that makes sense. All right, I can walk, hopefully, on a flat surface, right? Walk a straight line, I can handle that. All right, I can't walk this. I am not Superman, okay? So this is not going to happen. So this slope doesn't make sense, but this one does. So that's why the horizontal line has a slope of 0 and the vertical line has an undefined slope. Okay, vertical, up and down, I can't run it, it's an undefined slope. Okay? Let's put things in slope-intercept form. Now, when it comes to lines, you probably remember something from Algebra 1, hopefully more than you think, at least right now. So we could start anywhere. Everything can kind of be explained with each other. Okay, so I'm just going to dive right into one spot. So let's do slope-intercept form. And that's this, y equals mx plus b, where m is always your slope, right? We talked about that in the beginning. And b represents your y-intercept. Okay, now a y-intercept is when we have, it's where you hit the y-axis. You're intersecting the y-axis. Think of it like that, okay? You're hitting the y-axis. So if I've got my graph, all right, I know that if I'm on this line anywhere, if I'm any point on here, my x is going to be 0, right? So if we had a 0x, well, that would cancel and become just b. Okay, so b is when x is 0. And that's what we have with these examples. We have a slope of 2/5, and the y-intercept is 0, 17/5. So this is where we are on the y-axis. So that represents my b. So my answer is literally this. No, you don't have to show work for that one. Okay. All right. So see how simple it is? Just knowing that's the slope and that's a y-intercept. Sometimes they'll spell it out and say the slope is 0 like this. And then it goes through a point. So it may not tell you that it's a y-intercept, but we know because the x is 0. So that's automatically a b. So here we have y equals 0x plus 4. Now don't leave it like this, okay? We know we can simplify this. 0 times x is just 0, so here we should write y equals 4. Okay? For number 5, again they write it as m equals -1, and here they specifically say y-intercept is 0. Okay? So they didn't write it as a point, but they just told you that the b is 0. Okay, that's another way of writing it. So here we've got y equals -1x plus 0. Again, clean that up. I mean, technically it's the same answer, but we can simplify, make life a little easier, and just write y equals -x. Okay? All right, the next part, we want to find the slope and the y-intercept. So if I give you the equation, can you give me the other info? Well, if I want to find just the slope and the y-intercept, it should probably look like this. So, starting with number 6, g of x, that's just a fancy way of saying y. So we have this. So our slope is -3. And our y-intercept is at -15. Now here's the thing. I want to make sure that you know a y-intercept represents a point. So I want you to write it like a point, so put it as 0, -15. Okay, I want it written like this. If you write just -15, I'm giving you half credit. Okay? Number 7. Well, this one doesn't look like it's in the same format, but it actually is. Because think about, what do we have to multiply by x to make it not be there? 0. So here, our slope is 0, and our y-intercept is at -2. So 0, -2. All right, hopefully this is making sense. I'm going to highlight the only parts that I want as your answer. Everything else I write is just scratch work. All right, next part. All right, number 7. Now, I said next part and then I went back to number 7. Key thing here, notice what the slope was. 0. So the slope was 0. Well, hopefully we remember that represents, oh yeah, go back to here. Slope of 0 is a horizontal line. So if that equation of y equals is a horizontal line, what do you think x equals is? Hopefully you know that's going to be my vertical line. So you're right. I can't really put that as y equals because there is no y. So if there's no y, that's a vertical line, which means my slope is undefined. And in this case, all right, if here's my graph, x equals 5, go along your x-axis, 1, 2, 3, 4, 5. My graph is right here. All right, so there's my graph. Am I going to have a y-intercept? Nope. So you can say y-intercept? None. Okay, so x equals is the weird one. Yeah, it looks weird because it is weird. Okay, hopefully that helps you remember that. All right, let's do the next one. All right, number 9, that's not anywhere close to how I want it. I want it as y equals. So let's navigate it around. Okay, so I'm going to start by moving the 4x to the other side. So I get negative 3y equals negative 4x minus 6. Notice I put the 4x before the negative 6 because that's how it is over here. And then I need to divide everything by negative 3. So here we get y equals positive 4/3 x plus 2. So our slope in this one is 4/3, and our y-intercept is going to be 0, 2. All right. Next one. Number 10. So we want to, again, get the y by itself. So I'm going to move the 3x to the other side. So I get negative 4y equals negative 3x plus 12. Again, I put the 3x in front of the 12. Divide everything by negative 4. We get y equals 3/4 x minus 3. So in the last one, my slope is 3/4, and my y-intercept is going to be 0, negative 3. All right, so this is how I want you to write everything. Okay, I would leave your slopes as fractions and your y-intercepts as points. Next one. So let's see, number 11, we want to graph the equation. Well, great, if I know the slope and the y-intercept. So let's change it into y equals mx plus b. So for this first one, I'm going to move the 4x over. Divide by 3. This looks familiar. Maybe it's just the same numbers. Okay, so here we have our slope is negative 4/3. That's a terrible looking 3. And then our y-intercept is at 0, negative 2. This is why I wanted you to write them as a fraction and a point. It's because if I ask you to graph it, life is now much easier. The y-intercept is a point. Graph your point, 0, negative 2. So we're on the y-axis, hence y-intercept. My slope is negative 4/3. Remember, this is rise over run. So go down 4 and right 3. Down 4 and right 3. Okay, well if I went down and right, well that's the same as going the other direction, right? If I wanted to go from this point to this point, I would go up 4, left 3. So we can reverse it, but we have to reverse both of them. So we get 4, 3. Up 4, left 3. Up 4, left 3. So notice I went from edge to edge, just counting, right? That's super easy. All right. And I connect the dots, put arrows, because this graph doesn't stop here. If you don't put arrows, I think you think this is a segment and it's stopping. But we know better, so let's draw it like we know better, okay? All right, number 12. I really don't like this one because, woo, fractions are gross. So let's multiply by a common denominator. 3 and 6 can both go into 6. So let's multiply everything by 6. So again, I know I tend to lose people in the past, so I don't know if I'm going to lose you. So I'm going to literally write it all out. Multiply by 6 times everything. Okay? Then this, we can simplify. 6 divided by 3 is just 2, so we get 2x. 6 divided by 6 is just 1, so we get negative 1y. And then 6. Move your 2x over. And I really don't like that negative, so I'm going to divide. So I get positive y equals 2x minus 6. I change all the signs. There we go. So my slope is 2, and my y-intercept is at 0, comma, negative 6. So I graph 0, negative 6 on my y-axis, hence y-intercept. My slope, well, that's not a fraction, but I can make it a fraction. Put it over 1. Up 2, right 1. Up 2, right 1. And I know. It doesn't take that long, so just do it. Plus, if I'm not good at drawing straight lines, at least I have the dots saving me, okay? Because if I think your line is off, okay, if I'm like, something seems a little off, I'm going to start looking for actual points, okay? And if you don't have any points and it just looks like you just did this, well, yeah, I'm taking points off, okay? I'm going to think you have no idea what's going on and you just got lucky at being close, okay? Put your points in there because that tells me you know exactly where this line is supposed to go. Because drawing by hand, most of us aren't artists, okay? All right. One more slide, the last one. Okay, so again, these are your special cases. I don't know what it is about them, but kids hate them, they forget them, they mix them up all the time. Y equals, that looks pretty normal to my y equals mx plus b. So that, hopefully, we notice that similarity and we can remember the slope here is 0. And my y, okay, let me say that again. Y equals 0x minus 2. See how it's the same thing? So then my y-intercept is at 0, comma, negative 2. Okay, that's if we recognize it. But what if we don't? Okay, what if that's harder for us? Well, we can also graph anything, any and every equation by making a table. Let me do this in a different color. I'm going to do the blue. Okay, so if we wanted to make a table where my y equals negative 2, well, is there any rule about x? No x anywhere. So x can be 0 and y is, negative 2. X can be 3. Y is, still negative 2. X can be negative 15. Oh, look, y is still negative 2. It doesn't matter what I put here, anything. All my values for y are always negative 2. So if we graph 0, negative 2. We graph 3, negative 2. Negative 15, negative 2. If we graph all the y values at negative 2, we're going to get here, right? Even if I do the decimals. Yeah, my pen slips. Okay, there we go. I should say my stylus, but whatever. All right, so here's my horizontal line when y is negative 2. I went along the y-axis at negative 2 and drew a line. Okay, for number 14. Okay, hopefully we know that that looks different. There's no y. All right, if there's no y, that means it's a vertical line. Okay, so that means that the slope is undefined. All right, and there's probably not going to be a y-intercept. I mean, unless it's actually on the y-axis, right? But we can graph this one. Again, if we get confused, okay, we can always make a table. So think about this. X is 3. Okay, so if X is 3, Y is, well, 4? Sure, there's no Y there. What about when X is 3, Y is negative 2? Yep, that still holds true. What about when it's Y is 0, right? My Y. Okay, sorry, I was trying to fix that. When my Y is 0, oh, guess what? X is still 3. So here, all my X values are going to be 3, and I don't care what Y is. So I go to 3, 4, 3, 0, 3, 3, 3, negative 10. Okay, I'm going to get my vertical line with an undefined slope. I know. Just make it a little, yeah, that works. Okay. All right, so hopefully that makes sense. That's the basic lines that I think are fundamental for linear. Okay, everything else can kind of come off this stuff. Okay, all right, till next time.